Hi, welcome to the technical deep dive for the Inventory Framework plugin. Today is going to be a pretty lengthy video. There's not going to be a lot of editing, there's not going to be a lot of cuts, but these are the topics that we are going to be discussing today, and by the end of it, you should have a good understanding of how the entire system behind the entire framework that creates this framework. So to begin, actually, I'm gonna scroll through all the topics that are gonna be discussed. So if you see anything, the chapters will be linked. So if you wanna, for example, figure out what the construction settings for the objects and drivers are, you can see that here, and you can jump to this chapter and find this topic. But we're going to be starting from the top and going our way down the bottom. So one of the most important aspects of this system is the unique ID. If we go here, it is a fairly simple struct. There is an identity number and a parent component. And in blueprints, this can be seen as simply this. And you can do a bunch of you can figure out if two IDs are equal to each other, but this is essentially how the system separates two items from one another. So if I go into the tooltip and enable debug modes, and I go in game, you can see item ID near the bottom is 1 million, what is that, billion, 1,299,000,000, blah, blah, blah. And then this item is 1 billion, blah, 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 blah. And a problem that is quite common is that two items will be completely identical to one another. And this can also happen during the editor, while you're in the inventory helper. Two items can be extremely similar to one another, even including the same tile if you have disabled the collision for the inventory helper. And the system needs some way of distinguishing two items from one another. You can also see in the tooltip that at the very bottom is a container ID. Both items and containers can have IDs. You can search in the documentation just how frequently this is used, and there are several sections discussing how important it is. It is here, and I believe it is in here. You can search for it. Unique ID. You can see it is mentioned quite often. And I believe, yeah, it is mentioned here as well. Unique ID, so forth and so forth. Most importantly, the component is it's not possible for it to generate two identical unique IDs. Otherwise, the system can easily mismatch two items. And as we go along down here, you're going to see even more and more how much this unique ID system is used. This is greatly used in a lot of places to optimize network. So instead of sending the entire item struct over the network, you only send the unique ID, and the client and the server will have the same number for all items. So this gun, it has the same unique ID on the server and the client. And all other clients, actually, if I go to one of these chests, you can see that both of the clients have generated the same unique ID for this gun. So if I zoom in, so 179, 179. There is also a seed system which is used to make sure the client and servers generate the same unique ID. So if I scroll down here, there are two functions: generate unique ID and then generate a unique ID with seed. And you basically just provide a seed, and it will then always give you the same unique ID as long as the seed is the same. And this will also ensure that the same unique ID is never used twice. If it finds that a unique ID is already in use, it will just increment the seed by 1 and reinitialize. The next topic is item collision. And to demonstrate this, I'm going to quickly just go into the demo tile. And I'm going to go here and enable debug mode. I should actually comment this to explain what this is. But this basically gives you a view of what the tile map looks like. If we go into the container settings struct, this is the struct that you are editing whenever you are in either the class defaults or if you are modifying an item in the editor. In the details in the inventory, the container settings is just an array of this. And you can see here's your container name, your container type, so forth and so forth. And then down here is the tile map, which is just an array of integers. And these integers are the unique ID. So if we read here, some functions need to find out if a tile is occupied before widgets are valid. So we keep a list of all tiles and what items are occupying those tiles to optimize. The way this list works is that each index represents a tile. Index 15 is tile 15, index 43 is tile 43, so forth and so forth. Then the array element represents the unique ID of the item inside the container settings.items. So here's your array of items that is occupying that tile. This is the lightest and fastest way that I've seen to accomplish basically 2D item collision without going into some more complicated systems. This is an extremely simple but very effective system. This might get reworked in the future because it is a bit expensive to replicate this when the container is quite large. So if we look in-game, how this looks like is... Oh, why are you not visible? Is it... Do I need to make it visible? No. Do I need to enable tick? Yes, I do. So this is a bit messy to look at first, but what you'll see is that every tile that has no item in it is -1. And then here we can see 377. It's kind of over... It's not wrapping well into the tiles underneath this item, but you can see near the bottom, item ID, and the last 3 digits is 377. And this tile right here, the top right tile of this item, is trying to print out the item ID, and it's wrapping into the next tile. So it's a bit ugly, but you get the idea. So this item is occupying these 4 tiles. These 4 tiles are now trying to print their the item ID of the item that is inside of it. If I move this over here, you can see it goes empty, and these ones updates. That's why I have it hooked into event tick, so it constantly updates. Let's see. Yeah, -1 means there's no item occupying the tile. Yeah, I just showed here how to debug it. And yeah, the tile map might get reworked in the future. And I'll just disable this and disable tick. The tick is recommended to disable because of how many tiles can end up being created for some games. So for networking, most of the structs are in C++ because there is a not replicated property tag. So we can see for items the random min-max count once the component has been activated. This is only used once, so there's no point in replicating it because once it's been initialized, there's no point in replicating this. This is just a waste of RPCs. There is also the documentation. If you go into introduction, there's a drop down, and you go into how does the networking work, and it goes into detail of how most of the networking works. The actor component, the inventory component, tries to optimize RPC calls to a limited amount of clients by tracking who are interacting with it. These interactors are listeners, and they listen for any RPCs from the server. Here is kind of explaining why I didn't just go with a multicast or a rep notify. Depending on the scope of the game, rep notifies are completely acceptable. They're fine. But this inventory framework is supposed to scale up very well. So, for example, if we have two clients and one of them interacts with this chest and the other one does not, and he moves an item from this container, that RPC is not sent to this client because it's just not relevant. So that's one of the reasons why this system is handled like this, is to just simply optimize things. But this client, when he interacts, he will request the container data from the server, and he will get the most up-to-date. But now, since he is now interacting with this chest, he is now considered a listener. So when he moves an item, that RPC is also sent to this client. There is kind of a graph here to show what happens here is the function is called, so in this case move item is called, and it evaluates if the function should be replicated. So if it's single player, it calls the internal function. What you'll notice often is if we just look at increase item count, it's pretty simple, is that you have access to one function, and this function will attempt to replicate whatever your request is based on if you're in single player or in multiplayer. This is just so to reduce the amount of functions for you to call whenever you're trying to do things. So in here, let me see, where does it say? Let me see. This is to simplify the amount of functions exposed, as it can get very daunting to try and handle every replication scenario and making sure you're calling the right function. If you wish to modify how the replication is handled, you can always go into the functions, modify them, or enable the server/client/internal functions to be blueprint callable. And we can see here, adjust container size. There is an example with when you're removing an item, the replicated function is called for both clients and server. So the remove item function needs access to the non-replicated version. You can see here the display name for the internal function is non-replicated, but this function is called both on clients and server just to simplify the code. You can see here is a kind of code example. It's not a direct one by one example of It is increase item count. Yes, it is not an exact example just because like I don't want to post source code on the website. But you get the idea. The system tries to optimize the amount of RPCs it's trying to call. Let's see. Yes, clients are not allowed under any circumstance to call the try add new item function. This is simply because the try add new item, this function is creating a new item out of basically nothing. Whereas an item like this gun, it exists because an editor, a designer put it into the world and edited it. Whereas the try add new item function, if a client finds a way to call this function during a multiplayer session and finds some way of either manipulating memory addresses or find some way of tricking your programmer's code to pass in whatever data they want, this has the potential to add whatever item inside of your item database into a player's inventory, which is really bad. And it's one of the most horrible things that can happen in a multiplayer game. And for example, if you are using currency as an item, this has the possibility of infinitely generating currency. So there's a lot of safety guards around this function, and if they ever find a way to call it, I will try my best to get rid of whatever exploit they found. If we continue, yes, I have a feeling that a lot of people who are going to be using this framework aren't going to be too familiar with how networking inside of Unreal Engine works. So I believe it is called... Yes. For functions that modifies a component's data, such as moving an item or modifying an item stack count or modifying any other data, you must remember that clients only have authority over their own components or components on actors that they own. So in a gameplay session like this one, the client owns this character. So they're allowed to call network server functions on this actor, but this client is not allowed to call server RPCs on the chest or another actor's actor component. It's just, this is how Unreal Engine works. There's nothing I can do about it. Because of this, most functions require you to call the function on the client, on the component the client has authority over, even though the item you're trying to modify is not on that component. I think we can see an example with move item. You can see here from component and to component. There's also I believe this function. If we take a look, it will try and in the server function, it will, let's see, increase item count. Yeah, parent component. It will fetch the parent component from the item's item ID, a unique ID. And here you can see again the unique ID is being used. It's used very heavily. If we just look here, unique ID, in just the actor component is referenced 355 times. Yes, this is why when you look at the source code, the functions are getting the component the item belongs to through its UniqueID dot parent component and modifying that component's data through the component the client has authority over. If we then continue, yes, that is networking. Let's move on to infinite containers. So the infinite containers is technically just powered by a single variable, but a lot of code goes behind it to make it work. So if we look here, it belongs to item. It is a x and a y, and if we look at the source, the code comment, x refers to the index of the container settings array, and y refers to which item in said container settings ultimately owns this container. Item must have a attachment widget, though the attachment widget doesn't have to be valid. What it means is, if we look at the data set gun, here you can see attachment widget. It is just a class reference. It does not mean a constructed widget, because the constructed widget might not be valid. This, in essence, allows the component to have quote-unquote infinite containers. Once all items have been initialized, X is updated to the container's unique ID, and Y is updated to the item's unique ID. So it's easier to find items containers once items have been sorted and moved. As an example, I apologize if this is a bit small for 1080p viewers. Actually, let me just... If we take a look, we can see here the unique ID for this item, the gun. Oh, no, actually, this is the container. Here we can see... let me just use Epic Pen. Here we can see the unique ID for the item is 0, and the unique ID for the container is 0. And while it's in this state, we can find some containers here. And it says here, belongs to item 0, 0. And this gun is in container 0, and it is in its items, and it's in index 0. And if we convert this from raw state to editor state, you can see now that the X, so, whoops, the X has been turned into 913 blah blah blah, and the container ID for container 0 is 913 blah blah blah, and the Y has been updated to 101 blah blah blah, and the item's ID is 101 blah blah blah. Hopefully this was a good enough explanation of how it works, and then when we convert it back to raw states, you can see all the information is set back to 0, 0, 0, and so forth. Recursive structs are not allowed in Unreal Engine. This would have been a lot simpler and a lot more straightforward if recursive struct would be allowed. But I'm not even sure you're allowed to do that in C++, but I'm not 100% sure. You can do recursive objects, but that is more expensive and it's messier for save systems. And in general, you should be using the inventory helper to to modify items and their containers, because this is just a much better and simpler way of interacting with the inventory system. Working with an inventory system with 2 dimensions and technically 3 dimensions, with items having containers inside of them and items that can span multiple tiles. It's just messing around with it in this kind of one-dimensional list is really difficult and just not good for anyone's sanity. So yeah, infinite containers are really messy to manage without the component being initialized, and I would say it's also really messy to manage without the assistance of the inventory helper. The way it is set up is meant for optimal gameplay, but it has some problems with human error. The inventory already handles these human errors. So I understand that this is not the greatest workflow to have the containers underneath containers that belong to an item underneath the core item, the core actors components. But this is meant to scale well, and this kind of system achieves exactly that. It scales a lot better than trying to do something that is prettier for a designer to work in. So objects and drivers. This is probably the core system that most programmers and designers will be using to expand the inventory system. I should probably just leave it zoomed in like this. So if we take a look at the source codes for objects, let me see, objects, yes, construction policy and so forth. Actually, no, let's just stay here. So you have 2 ways of getting a item's driver. It's get driver by, alright, it's get object by class for item and get object by tag for item. And the context menu retrieves objects by getting any objects that are labeled as this. So if we take a look at apple, oh whoops, not the texture, you can see here the consumable object is using this tag items.objects.use, and that is how the context menu is retrieving that object. And to construct a driver, you use the getItemDriver function, and you have the option to create it. If no driver exists for this object, attempt to create it. So let me see. Yeah, this container is optional, and if you were to, for example, migrate this over to your project, there are some moments where you're gonna have to refill the tags, because the tags are saved inside of, I believe here, yes, gameplay tags list items.object.use. If we continue down the settings, you can see here the code comment. I can get it bigger over here. Constructed basically means the inventory component will create the item driver to drive any logic. So for example, this item object consumable it will create this item component called the item driver consumable. And this is simply a actor component that is attached to whoever owns the item. Let me see. Obviously, this is more expensive because you are creating an actor component and attaching it. That is just its CPU cycles, but it shouldn't be that expensive. You probably never notice it. The item driver is viable for replication. Instance U objects are known to be very buggy whenever you try and modify the data inside of them, since this method constructs a whole new item driver component. We can get around that buggy behavior. And third, timers, delays, animations, async tasks, and RPCs will work. And you can see that in the consumable. We can see there is there's an async load, there's a multicast, there's a play montage, and so forth. There's even a delay. There's everything. Data only. Currently, the example project doesn't have an example of this, but this basically means that the inventory will not create an item driver. And you can see if we change this to data only, pretty much all the options go away. It's only when you change it to constructed that you get the networking method, the construction policy, and what class to use. Though this will rarely ever be any other class. You will most likely want to set it up in your class defaults here. No, class settings, I believe. No. Why is it not showing up? It should be here. Oh, no, this is the driver. IO consumable. Don't show me engine contents. Yes, class default. You'll want to set up your item driver here. I can't imagine many scenarios where you will want to change the item driver, but it's there nonetheless. And data only means that you are meaning to use it. Let's see here. That you are meaning to just read it out here. So for example, we can cast this to consumable. And you are meaning to just get the animation here, for example, or health to restore. You are just reading the variables from the object directly. There's no construction going on. But and this is obviously cheaper, but you should not be using timers, delays, or async tasks, or actually it covers here. This object will not get replicated over the network, and no data inside of it is meant to be modified at runtime. So yeah, construct it for when you want dynamic events that can modify variables or run any kind of meaningful functions, or like timers, delays, animations, and so forth, or have replication. This is just if you want any kind of variable. For example, you might have a attributes object where you assign this for like this gun, it deals 10 damage per bullet, or it grants the character like 3 strength or something like that. And then you read those numbers during your gameplay logic and grant them those numbers. Yeah, here, to read the data from this object, you will want to call either actually, we moved this from the actor component, is now in the function library. So it's either get object by class or get object by tag, and then casting to this object. And then we have the networking, construction, and item driver. And these are only um, these are only relevant when the construction method is set to construct it. So both means it will be both client and server. It will get replicated over the network. Well, it will get constructed on the server and then eventually replicated to the clients. I do recommend, if you're using a single player game, that you just leave it to both, just because if you ever want to try multiplayer, then most things will just they will have a higher chance of quote unquote just working. I believe it is mentioned somewhere around here. No, it's mentioned somewhere. So, yeah, for single player games, none of these options will change their behavior. They will all work, but it is recommended to keep them set to both, just in case you ever want to try multiplayer. So the construction policy is a little bit more complicated, but it's probably the most powerful out of all these options. So per actor means only one copy of the item driver is allowed per item. Example, you have 2 stacks of apples. You are allowed to use stack 1 once until its logic destroys the component. But you are allowed to use stack 2 while stack 1 is still finishing. And then per use is just a new item driver will get created per use of this object. And then custom, whenever a new copy of the item driver has a chance to spawn, it'll ask a overwritable function called allow new instance. Override this function inside this uObjects class. It is... Okay, my scroll decided to not go down. Oh, I'm assuming it's because I changed my Windows scaling during the recording. But if you go here, item consumable, you have one function that's overridable, and that is allow new instance. And this will basically just ask, should a new instance of this object of this driver be allowed? And you just say yes or no. You can cast here to like get player pawn and get their get inventory component or something like that. You can really do whatever you want with this function. Let's see. Yes, the note item inside of the example project is a good example of a client only object, meaning it is only created for the client that tries to use the note. There is an event system. If I resize here, this will work. So there are pesky moments. This is actually perfect in the context menu. So the Apple item, for example, is both a client and server, but the client is the one that's initiating the construction. And in this widget, the client calls this function, it gets the object, it then attempts to create the item driver. But because this is an RPC event, that means there's not going to be any return value. We can't call like use. We can't call this function because there is at least 1 frame delay here. And that's really annoying when you're writing your code. Your alternative, your primary way would then be to bind to when a driver is it created or driver started, and then binding to this. It's just really messy. So the event allows you to associate a tag with any kind of function that you want. So for those of you who don't know, for gameplay tags, you can do a switch statement and now just add your tag here. And in the example project, the items.objects.use is hooked into the item used function. And if we look at the get item driver, if we look at yes, here, event, it checks if it's valid. It has constructed, yes, it has constructed the item driver, and it now gets that new item driver that it's created. It calls this function. Remember, there's the client function. Here on the server function, yeah, actually it does it on both. It will broadcast this has been created, it has started, but it will also call this function activate event. And in the blueprint child, I do recommend that you create a blueprint child directly as a child of the item driver, and then all of your item drivers are not children of the C++ child, of the C++ parent. They should be children of the blueprint version, just so it's easier to handle overridable functions like this. And you also have many other functions that you can overwrite. And you can now start creating your blueprint functions here and adding any kind of tag event here. But you can see here in the client function, so the client is calling this, and he is passing in this event. And that will eventually propagate to here, where the server will call this function. Whoops. And then it's called over here. And this is how you kind of go from client to server in a very simple manner. I believe the item driver has a code comment for yes, this is designed to be overridden at a blueprint level. Allows you to call certain functions based on attack. Yes, this basically covers what I've been saying. So the equipment system is probably a bit over the top. The point, the main reason why it is so complicated is to handle scenarios where you might have two skeletal meshes. For those of you who don't know, in first-person shooters, there are two skeletal meshes. There's the skeletal mesh that other players see, so owner no see would be checked, which would be the full body mesh. And then there are the arms mesh, which would be only owner see. And that is what a lot of these what this struct attempts to fulfill. You can have certain moments to wait for. You can have some animations wait until another animation has triggered some sort of animation notify. This would be an example of the player spawns a gun, and then during a notify, he tries to cock the pistol or something like that, and you then want to play an animation on that pistol. That's where you would try something like the trigger the wait for notify. And then there's also play animation mesh with tag. This will basically go up the hierarchy chain of the item that owns the mesh that you're trying to play the animation on, the item that this item belongs to. So if you're trying to play an animation on a gun when a sight is attached, but you have two guns, you have one on your waist and one on your back, or one in your arms, it will then try to climb up the hierarchy chain until it finds a mesh with this tag. So it would then always find the gun that the sight belongs to, and it wouldn't mess up which gun it belongs to. Then there are equip animations, do not equip to mesh. This is, you check it, and now you're basically just playing the animation. So, this would be probably an example of... I'm not really sure where you would use this. But yeah, equip item on notify. This is used as an example here. Equip item on notify. There's this animation has a notify called equip item, and when that is met, then it will actually spawn the item and equip it to the mesh. And then there's just, the player mesh. You can see that on the mesh here. You can see in the tags, it has player mesh on it. And you can also see that here, equip socket and attach the component with tag. The backpack, I believe, is only one component. Yes, it is only one static mesh component. Let me see. And this really allows you to set up your hierarchy in whatever way you want. What you'll notice in the physical representation, you only have a scene component and an arrow component, and the arrow component is only for editor. I don't think it's I believe this should be checked, but I'm gonna this should be checked. So this is only used for debugging purposes, and it was very important in this framework that there's nothing dictating how you set up your hierarchy. So the gun is a good example of this. I've just gone absolutely wild with components as a stress test to see how the preview system and the inspection system would handle a very badly set up item. Obviously, for optimization purposes, you would create an actual static mesh component and not have it be comprised of all these different meshes. Were there any more settings? I believe this was deprecated or not. I'm not sure. If this is still in it when it's released, it's probably still there. But sometimes you don't want players to unequip an item while an animation is playing, and this boolean will just say once this animation is done, then remove it from the network queue. So to kind of further explain how the equipment, the animations are handled, basically the equipment driver will send off all the animations onto an object that only exists on the server, I believe. This should be replicated. It should be. But this will send it off to multiple different objects, and those objects can now listen to each other's notifies. This is technically how it's handled inside of the gameplay ability system for Unreal Engine. I believe gameplay ability system. I believe it's this plugin. But the gameplay ability system is slowly becoming an industry standard, and I believe in the documentation it says equipping and unequipping. This kind of goes into more detail of how this works, but I believe it mentions gas. Yeah, this driver attempts to copy the system that is used in gas with its play, montage, and wait function, which creates an object that handles the animation, but I want to keep mine inside of blueprints. Yeah, never write data to any object, only read from them. Gameplay tags can be used quite a lot. I don't use them that much just because the migration is a bit of a pain. The preview system. So the preview system, quote unquote, should work on any actor that you specify. As of the release of the plugin, there is a bug where refreshing the preview actor is behaving differently in a shipping build than while in editor. From the code, it's supposed to behave exactly the same, but for whatever reason, it's not. I'm gonna have to investigate why that is. But other than that, the preview system, the entire system is encapsulated kind of into this one actor inside the documentation. So this covers pretty much how it works. Let me see. Yeah, there are 5 files revolving around it. There's also the inspect, which extends the usability of the preview system. And if you want to use the preview actor for your own system, for example, a transmog like sharing system or something like that, you might want to explore this widget and how it utilizes the actor preview system. The main thing to consider is that there are 2 actors. There's the collider, and then there's the preview actor itself. The collider is simply a large volume. Let me see. Are you not visible? I'm not sure why it's not visible, but it should be. Visible. Yes, it's simply a large collider to test for collision, to not have any other lights interact with the preview actor. So the preview actor has currently is refresh. Currently, the only lighting channel it's responding to is channel 1. Did the documentation say was channel 2? Channel... yeah, that's a typo. It's supposed to be channel 1. But... And this is important if you have a day and night system, or you have a lot of lights during... a lot of visual changes during your gameplay. But the problem is that other preview actors, if they spawn too close to one another, their lighting can affect one another. And even though I'm spawning them at ridiculously long ranges of random location, this scenario was still happening where 2 previews were colliding with one another. And this is where the collider comes in. which you spawn first. If we take a look at the inspect system, it spawns this one, and then it tries to adjust the location but always spawn, and then it spawns the actual preview actor inside of the collider. And also one of the main things to keep in mind is that the owning actor is the actor that it will try and duplicate the appearance of. And in some cases, there is no actor in the world to duplicate the appearance of. And that's where this item inspection system comes in, because in, for example, this gun, there is no actor in the world for it to inspect. So it has to spawn one in the world. And that's where things can get a bit expensive. But as long as you, let's see, it is in UI, use static capture. This basically means it will spawn the actor for 1 frame, take a snapshot of it, and then destroy it. But obviously for the preview system, actually no, it does destroy it instantly. Let's see. I believe I showed the debugging features inside the intro video. For those of you who didn't watch that, or probably don't remember, there's a toggle debug here. And I should actually also go into how to generate the icon. So you can save the settings that you have here. It should be updating. Toggle debug. Yes, now it's updating. You can save these numbers. You can also manually input. You can save to asset, and it will say here data asset has been modified. You need to go into it, press save, and you can see the rotation values that we put into here have been saved to the item data asset itself. So now next time when we open, it will remember those settings. But there is also a save icon button that is grayed out, and that's because you have to go into this dropdown, generate an item icon, and now you can set these settings. You can change how close it is. You can change the location. So if you want to move it a little bit in that direction, you can do that. And then you can set this slider over here and press the buttons now to rotate it. You can also use your scroll wheel to zoom in and out, and also just click and drag. And when you press save icon, it might lag. I've actually never tested this in a multiplayer session. You, as the texture created, you have to save it, then right-click the asset and click on asset actions reload. So we're going to set here set icon for developer image. We have to go out here. We have to go into the folder that this item data asset is found. And we can see there's a new asset that's been created, but it doesn't look correct. We have to right-click it, save, and then we have to go into asset actions and reload. It might lag, but now it is functioning. And we can see here, developer image, it has been saved. If we go into inventory helper, you can see in the item database that the icon has been saved. And also the developer image is being used in the inventory helper because the generated item icons is not supported, and it will not be supported in any future releases. It might change if I can find some way of doing it more friendly for the actor outliner system. Because if you're generating item icons, it's going to mess around with here. But yeah, I've stated here the reasons why the generated item icons are not featured. Oops, I have messed you up. Yeah, the snapping issue that you can see when you can see here he's kind of breathing in and out, and when we do things, you can see he kind of snaps. This is an issue that is high on my list, and it will most likely be resolved in 1.1. We're almost finished. So next up is creating more in-editor tools. Most functions from the inventory system require unique IDs to be valid. And this is why the component has an editor state. And you can read more about the 3 states that the component can be in, though the initialized state is something that you'll never be interacting with as a designer, because it is only meant for gameplay logic while you're in a valid gameplay session. And that's why there's only 2 buttons to convert it from editor state or to raw state. Your custom functions, so any functions that you make yourself, you can probably also read here in working in the system and creating custom functions. Your functions should just always assume that unique IDs are valid. Otherwise, you'd be spending a lot of time writing redundant code. Though you should always be checking, for example, if I believe we looked at I don't know, let's just search increase item count. We are still checking if the parent component is valid. You can also check if a unique ID is valid. I believe it's here. Is unique ID valid? And that is just checking if the identity number has been set and if the parent component is valid. But you should never be trying to write code that works while the unique ID is invalid. You should just return and spit out some kind of error. Remember to refresh or reopen your editor utility widgets after compiling a widget that it is using. So, for example, in the inventory helper, if you modify the demo tile, if it's still open, yes, there it is. For example, if we do this and we just change tick to enabled, if we're debugging this, you can see it all vanishes, and also a lot of delegates will break. So for the inventory helper, pressing update will wipe out all widgets and reconstruct them, which will work. But you also, in some cases, you might want to just close it and reopen it. And also, I'm aware that there's a bug where if you have your Windows scaling set to something else than 100, then there's a weird padding issue that occurs. If I change it back to 100, you can see it fixes itself. Though I'm going to leave it a little bit zoomed in just for the sake of the video. Editor utility widgets as of 5.1, I don't know if this is fixed in 5.2, are not labeling actors as dirty. And this basically means that there's an asterisk and notifying you that there is some change that needs to be saved. For now, you need to manually label actors as dirty or your changes won't be saved. You can see an example of this in... there is a function that... Oh, whoops, not edit. Run. There is a function called mark asset dirty, and this is just marking the package as dirty. For some reason, this is not available in normal Blueprint use, and this is only usable inside of editor utility widgets, as far as I believe. So if you're in like here and you're trying to mark assets, actually you can. Is it actors that can't do that? Oh, this was not showing up the last time I was trying this. I might be misremembering something, but let me see. Oh, I had it inside of with editor, and I believe that is what limits it. So process item. Yes, that is. Yeah, that's why. That's why. So you can access it right now, and I believe if you. Oh, I did something illegal. I inspect. Right now it is not labeled as dirty. Save icon and that as developer image. No, it does not label it as dirty. That is something that I might fix in the future. Now that I know that that was the reason. You learn something new every day. Yes, that is it, I believe. You should have a fairly good understanding of how the system works now. As it is mentioned here in the documentation, the foundation of virtually every inventory system is simply tiles and items that slot into those tiles, and then there is some kind of container hosting those tiles. And the let me see more data. The container settings is simply the ultimate wrapper that is wrapping around all those. Oh, I actually forgot saving systems. So there is a very basic save system, and really all you're trying to do is saving and restoring the container settings inside the actor component. If we, I believe it is in escape screen, there is a save and load, and it is very, very simple. And you can also see here it's calling stop. It is setting the container settings, and then it's resuming the component. And that is about it. I believe for multiplayer, I don't know much about restoring saved data during a multiplayer session. I believe you need to request from the server the container settings, because you do not want to trust the client's save data, because they obviously have access to that file. They can maliciously modify that file, and then your server should just not trust anything from the client as sensitive as a save file. I don't have much experience in that field. You're probably better off doing some research on how to do save and load systems for multiplayer games or that kind of operation. Though, in general, the save and load system in Unreal Engine at a Blueprint level is really, really bad. And in my opinion, it's in dire need of a complete revamp. I do recommend a plugin called Savior, which is about 80 USD, and trust me, it will save you so much time. Basically, all you need to do to save a variable is to just press save game, and it will then automatically serialize and restore it for you. And it does a lot of other things beneath the hood. So I can't recommend Savior enough. It really helps a lot. And yeah, I recommend if you're going to be making any kind of advanced low serialization system, that you just go into C++, because the blueprint level is just extremely bad. You also have a function called get containers for save state, and this function will simply provide a copy of the container settings, but with some data modified so it's more optimized and better for save game files. And basically it sets them up in such a state that when you call start component, it will pretty much always work. Or, well, it should always work, unless you have done something horrifyingly wrong. I think that is it. This has been a very lengthy video, but there is also a lot to cover in this kind of inventory system. Thank you for watching, and I hope to see you in the next one. Bye-bye.